Welcome to everyone. My name is Bashair, and today I will present a short lecture to take a look at previous study and research that study the influence of biochar application on different type of soil in greenhouse gas emission. Let's start. First of all, let's take a look at the main subject of this presentation. At the beginning, I will give a short introduction about biochars and greenhouse gases emission. Then I will highlight the main objective of this article review. After that, we can focus on the influence of biochars on carbon dioxide emissions. Then we will talk about methane emissions. After that, nitrous oxide emissions, and at the end we can summarize and conclude all that. What is biochar? Biochar is charcoal produced under pyrolysis process in absence and limitation of oxygen, which produce carbon-rich material that used for soil amendment. There are some factors that change the quality of biochar, such as the source of material, the conditions of pyrolysis process, and the interaction of biochar with the soil. From that, we understand that the biochar used as a soil amendment. Also, the biochar used to reduce the impact of climate change that is directly changed by increasing the emissions of greenhouse gases. However, the emission of greenhouse gases increase from various sources, such as fossil fuel, cement protections, applications of fertilizer, and others. In addition, the main greenhouse gases that is related to the climate change are carbon dioxide, nitrous oxide, and methane, and the soil considered to contribute their cycle. Many microbes that live in the soil produce carbon dioxide through respiration process. Moreover, the emissions of nitrous oxide from the soil produced through anaerobic denitrification and aerobic denitrification process. Also, the emission of the methane from the soil produced by methanogenetic archaea through methanogenesis process. The main objective of this article review is to highlight the interactions of different soil types with different biochar depend on pyrolysis temperature and biomass on the emission of the greenhouse gases such as carbon dioxide, methane, and nitrous oxide. Let's start. First thing, let's start about carbon dioxide emission from different types of the soil. There are some research that conduct to study the emission of carbon dioxide from sandy loam soils, and they use a different type of biochar as this table shows. There is an increase in the carbon dioxide emissions about 13% compared to the control treatment when they use woolly wood as swine manure as biochar biomass at pyrolysis temperatures 350 Celsius. However, there is decrease in the emission of carbon dioxide by 18 to 25% when they use corn residual as biochar biomass, and the pyrolysis temperature were between 400 to 500 Celsius. Also, there is slightly reduction in carbon dioxide emission when they increase the pyrolysis temperatures to 700 Celsius and they use swine manure as biochar biomass, and there is no difference when in the emissions of carbon dioxide compared to the control treatment when they use wood manure as I mean wall wood as the same pyrolysis temperature. Many studies conduct to measure the emission of carbon dioxide from silty loam soil with biochar application, and most of them have the same result. There is an increase in the carbon dioxide emission by using different type of biochar depend on the pyrolysis temperature and biomass. And from the table on the slide, we can see that the emission of carbon dioxide was decreased as the pyrolysis temperature increased. So, at the higher emission was at low pyrolysis temperature, which is 400 Celsius, and the lower emission was at high pyrolysis temperature, which is as 600 Celsius. Moreover, the research that conduct on clay loam soil shows a fluctuation in the result, where in low temperature 350 Celsius there is a high emission of carbon dioxide, and when the same biochar biomass used at 700, the pyrolysis temperature shows insignificant emission compared to the control treatment. However, the study that conducted in 2012 shows a decrease in the emission of carbon dioxide when they use rice husk as at pyrolysis temperature 450 Celsius. From the result above, we can see that at low pyrolysis temperature there is an increase in the carbon dioxide emissions, and that could be described by there is an increasing in respirations, in soil respiration of the microbes that is related to the available carbons in the soil. Also, we can explain that there is a carbon loss from biochar by a biotic process. Let's now move on. Now, let's talk about methane emissions after applying biochar on different soil textures. In sandy loam soil, many studies conduct to measure the methane emission after applying different biochar, and the table in the slide shows that there is a decrease in the methane emission compared to the control treatment under different temperature and by use different biochar biomass. Also, the research in silty loam soil after applying biochar shows that the emission of methane was lower than the control treatment. However, in low pyrolysis temperature, the methane emissions did not show a significant difference compared with the control treatment. But as the temperature of pyrolysis increase, there is a significant reduction in the methane emission, as the tables in the slide present. And we can conduct that we have several research, they use different biochar biomass. The studies in clay loam soil shows a decrease in the methane emissions by using different biochar biomass under different pyrolysis temperatures. And from the result of the methane emissions, overall we can see that the methane emissions after applying biochars was decreased. And to explain that, let's move to the next slide. And overall, the above result shows a reductions on the methane emissions, and we can explain that because of the applications of biochar will decrease soil bulk density, Therefore, there will be an increase in soil aerations and decrease the methanogenesis process that will affect and decrease the methane emissions. Another explanation is that the biochar will affect the soil temperatures. Therefore, the methane producing bacteria and methane oxiding bacteria activity will be affected also. Now, let's talk about nitrous oxide emissions after applying biochars on different soil types. Several research was conducted to study the nitrous oxide emission in sandy loam soil, and overall, the result shows that there is a reduction in nitrous oxide emission after applying biochars. The tables in the slide shows a summary of some of those studies where they use different type of biomass under different pyrolysis temperature. And we can see in 2013 the study that used woolly wood and swan manure show a slight reduction in nitrous oxide emissions at 350 Celsius. But when they increase the pyrolysis temperatures to 700 Celsius, the percentage of reductions was increasing for 50%. Also in silt loam soils, the nitrous oxide emissions was decreased, and the tables in the slide present and summarize some of those studies who measure the nitrous oxide emission after applying biochar in silty loam soil. However, there were no much studies that conduct on clay loam soil to measure the emissions of nitrous oxide after applying biochar, and the existing studies have a different result. There is non significant difference in the nitrous oxide emissions after applying biochars of corn stalk at pyrolysis temperature 400 Celsius. However, there is a significant reductions in the nitrous oxide emissions from the soil after applying rice husk biochar at pyrolysis temperature 450. And to explain that, let's move to the next slide. We can explain that because biochar will increase the soil pH, therefore the soil aeration will increase, and that will affect by decrease the denitrification process, and therefore the nitrous emissions will decrease. Also, the retentions of the nitrate in biochar surface will decrease the nitrous emissions. And the last sections in our presentation will be the conclusion. The use of biochar is not limited for a soil amendment, but also could be used as climate change amendment because it has a significant effect on greenhouse gases emission. However, from previous research, we see that there is a fluctuation in carbon dioxide emission as applying biochars depend on the type of the soil, biomass, and the pyrolysis temperature. However, there is a reduction. There is an overall reduction in the methane and nitrous oxide emission after applying biochar for different type of the soil and under different pyrolysis temperature and biomass. For future perspective, many research need to conduct to study the effect of biochar on greenhouse gases emission for long term. And also I think they need more studies to conduct to use date palm as biochar biomass. That's all. Thank you for your listening. Any question?